Alright, UFC 324002N, 16th of January 2004, Unified Facility Criteria, Wastewater Treatment System Augmenting Handbook, approved for public release, distribution unlimited. Alright, Section 5, oil water separators. Section 1, this section addresses the military application of oil water separators to provide the general information of the oil water separators, as well as separate information on determining the need for oil water separators, principles of oil water separation. Oil water separators design criteria for selection of the oil water separator technology. Emphasis is given to conventional parallel plate gravity for the oil water separators, which are prevailing installed at military bases. Other technologies such as flotation, filtration, and absorption are briefly discussed. These topics are addressed with the Water Environmental Federation MOP 8 oil classification. Oily wastewaters are generated in the industrial maintenance areas of the military installation for such activities with the aircraft vehicle maintenance washing. Oil presents the wastewater may be several types, including gasoline, jet fuel, diesel fuel, lubricants, miscellaneous detergents. Regardless of the types, they are typically classified in three major categories: free, emulsified, and dissolved. 521. Free oil. Free oil consists of a discrete globes large enough to raise the result of the buoyant force of form an oil layer over the top of the water. Theoretically, the oil globes are as small as 20 microns. It can be classified as free oil. However, the research indicates the size of the oil globes must have been approximately 150 microns greater to be more effectively removed in conventionally gravity separator chamber. 522. Emulsified oil. Emulsified oil exists in smaller droplets, approximately 1 to 20 microns, which are stable to depression with the water and incapable of rising to the form of a separate oil layer without additional chemical treatment. The dissolved oil is soluble in water and is also incapable of removal with gravity separation. 523. Oil wastes. Oil waste discharged from the military base may include any of all these classifications, which most of the oil waste is originally in free state. The cleaning of the agents commonly used in washing floors, vehicles, aircraft, other equipment of military installation are designed to increase the solvency of the oil and water they cause. The oil to become emulsified. Additionally, free oil can be mechanically emulsified through the excessive agitation or turbulence, such as that caused by the high velocity of pumping. Central finger pumps are especially prone to the emulsified oil. Conventional methods of measuring oil to grease do not differential free, emulsified, or dissolved oil. Method to provide differentiation is described in American Petroleum Institute Publication 421, Design of Operation of Oil Water Separators. 5.3. Basis for consideration of oil water separators. Primarily, oil water separation is implemented at the military installation to comply with the federal, state, local requirements and to minimize the impacts of oil, grease, and collection system of the downstream treatment systems. These conditions are further discussed. 531. Regulatory compliance. Regulations which require the use of the oil water separators are primarily associated with the Public Law 104, Water Quality Act of 1987, with the discharge of the wastewater with the water of the United States is regulated with the Title 40 CFR Section 402, National Pollutant Department Environmental System, Elimination System. Permit required of the Title 40 CFR Section 403 oil wastewater discharge to sewers under the General Treatment Regulations. Stormwater permit requirements under Title 40 CFR Section 122.26. These regulations are enforced by the federal, state, local regulatory authorities. Military certificates are also enforced with the regulations of oil wastewater being discharged by the federally owned treatment works governed under the Federal Facility Compliance Act. Discharge of oil wastewater fuel storage areas must be permitted with the National Pollutant Department Elimination System program. This installation shall implement the pollution prevention measurement, the best management practices to minimize and eliminate the oil wastewater contact with the discharge of the diked area of the fuel storage area, which will eliminate the need for oil water separation. Spill prevention control measurement requirements to Title 40 CFR 112.7. As for emergency spill control, actions should be considered separate for routine operations. However, provisions for the general pre-treatment regulations apply with the oil waste to the discharge to the sewer systems are found in Section 403.5b. These provisions prohibit the discharge of any of the following: any pollutant which interferes with the pass-through treatment works, pollutants which create a fire or explosion hazard within the sewer system, petroleum oil, non-biodegradable cutting oil, and products of mineral oil origin in amounts that will cause interference with the pass or exceed effluent discharge limits. Some sewer ordinances also contain specific numerical limits. Pollution, which results from the presence of the toxic gases, vapors, fumes within the sewage system that may cause acute worker health or safety problems. In addition to these provisions of the portable POTW sewer, ordinances prohibit the oil and grease discharge for the could accumulate with the collection of the sewage pipe without obstruction flow for the could accumulate with the sludge treatment works, resulting in hazardous substances disposal requirements. 532 related impacts on collection treatment system and the additional impacts outlined with the regulation wastewater containing the significant quality of the oil, grease, and impact of the collection treatment system in the following ways. Accumulation of oil and grease in the collection with the piping causing obstruction of flow, accumulation and treatment of facility sludge, resulting in hazardous substances disposal requirements. For these reasons, the wastewater discharge for the maintenance facility wash rack should be managed to prevent adverse effect for the treatment plant and protect the environmental release for the surface waters. 5.4. Evaluating the need of oil wastewater separators. Normal oil water separators exist on the military bases, some of which are not needed or not accomplished their intended purpose. The missing application and inadequate performance have resulted from the poor design, improper selection for the pre-manufactured units, failure to inadequately understand the characteristics of wastewater being treated and pre-treated, lack of the proper maintenance. Consequently, the need of the oil wastewater separator should be carefully evaluated before undertaking its design. Figure 10 presents a decision diagram determining whether the oil water waste separator is needed to a particular location. In using the decision diagram, the following sources of control issues should be considered. Alright, this is for the discussion tree for the oil water separators. Alright, if you go from the oil, is the oil settable solids producing process needs sustaining mission? No. Eliminate the process. Alright. Also stop. Goes to stop. Does the level of the on the land of the grease and settable with the solids discharged by the process exceed the capability downstream process for exceeding discharge permanent limits? No, and then stop. If yes, can the level of oil and grease or settable solids reduce the source of control? Yes, reduce the level of oil and grease settled pot solids at the source of pollution and prevention techniques. Also go back to, from there, go to, does the oil, land, and grease and settable solids discharge process exceed the capability downstream process exceeding limits exceed discharge? Can the level of the oil, grease, and settable solids reduce the source controllability? No. Does the level of free floating oil and settable solids discharged by the process exceed with the capability downstream process or exceed discharge? If no, does the level of the emulsified oil discharge process exceed the capacity of the downstream process and oil discharge limits? If no, then stop. Does the level free floating settable solids discharged by the process exceeding the capability of the downstream process exceeding the discharge permanent limits? Yes, provide an oily water separator. If yes, does the level of the floating oil to separate settable solids discharged by the oil water separator exceed the capability of the downstream process? Does it exceed discharge permit? Yes, provide additional treatment steps, and then install emulsification emulsions removal facility. Handbook 1059. Alright, also I skipped this by accident. Does the level of the emulsified oil discharge process exceed capacity downstream processes of the discharge? If can the level of the emulsified adequately reduce the source? Yes, sir. If yes, then can the level of the emulsified oil adequately reduce at the source? Goes back, does the level of emulsified discharge process exceed the downstream process discharge limits? If no, then stop. Alright, using detergent to clean up the work area to increase the emulsification and inhabit the gravity oil water separation. Even the high pressure water will always cover the emulsification as generally with low detrimental oil water separation than used for the detergents. Use dry absorbents should be considerably minimized. The amount of the oil reaching sewer to dry absorbent may be collectively disposed of the solid waste materials. If possible, wet processes should be replaced, but the dry process floor drains should be plugged. See, implementation of the point of source of control and eliminate the reduced wastewater volume contamination control. For example, the use of oil water may be segregated for the disposal or reuse rather than allowing them to enter the wastewater stream. And implementing point source of the controls may also more economically provide a wastewater treatment system for the point of source. The techniques include the change of the modification, material recovery, material substitution, wastewater segregation, and water reuse recycling. D. Considering changing the point of the discharge, negotiate less than stringent requirements to protect the sensitive environmental areas. For example, it may be practical to reroute the storm water permitted to outfall through the sanitation indirect discharge, but the storm water flows to low at the permitted stormwater discharge of the overall overlie. Restrictive and extraneous stormwater should be excluded from the sanitary systems. Stormwater pollution prevention plans should be implemented in best management practices within the minimized or eliminate need for the oil-water separator in most instances. Formation of oil emulsions should be minimized. The emulsions should be segregated with the special treatment whenever possible. Emulsions are usually complex and bench pilot and plant testing is generally necessary to determine the effective method of the emulsion breaking. Correct processing operating practices should be investigated to determine the good housekeeping practices employed, and if changes can be made with reduced wastewater materials used for the excess water